Students, today we shall go for learning about the minimum spanning tree and different algorithms of minimum spanning tree like kruskal algorithm and prim's algorithm. Now, before that, we shall learn what is minimum spanning tree and what is the difference between a spanning tree and the minimum spanning tree, and then we shall go for one of the algorithm, that is a kruskals algorithm. Now, what is a minimum spanning tree or what is a spanning tree? Spanning tree is basically used to find the minimum path to connect all nodes in a graph. Therefore, these spanning trees are nothing but a subpart of a graph. Okay, and we will not form a cycle. We will not have a cycle, and in one graph there may be any number of spanning trees. Usually, the minimum spanning tree concept we will use in various applications like civil network planning, like when you want to do any plumbing operations in your plumbing work in your house, new build house, or any electrical wiring you want to do, then in that we can apply the minimum spanning tree. And not only that, we can even apply this concept in the network routing protocols also. Therefore, when you are routing a packet from a one source to the destination, therefore your route should be an efficient route. That means a minimum path you should have. Therefore, so that you can route the packet from the source to the destination very easily within a short time. Therefore, that is one application where we will use the spanning tree and cluster analysis. These are the various applications where we use the spanning tree. Now, when you go for a minimum spanning tree, the cost of all the spanning trees, when you come, if you compare the spanning trees, we will, as I said that for the one given graph, we will get many number of spanning trees, and among that, which spanning tree is minimum, its cost is minimum, then that is called as a minimum spanning tree. Now let us understand clearly by considering one example. Now let us take, this is our graph, is example graph. Okay, and here we have totally 4 nodes and 1 2 3 4 5 edges, right? Therefore this is an undirected graph. Now in this undirected graph I can form many spanning trees, like I can form like this. That is nothing but 4 3 2. This is one graph I can one minimum spanning tree I can form, and I can form 1 2 5. Okay, from every node we can form a spanning tree. Okay, if you go for first node point of view, you can form a spanning tree. If you go for second node point of view, you can form a spanning tree. Third node, fourth node, every point, every node we can form a spanning tree. But the thing is, which one is minimum? Okay, like for example, I have a spanning tree like this. See here, I have considered only these 3 edges, 4 5 2. This is one spanning tree. Okay, now as I said, tree is nothing but a part of the graph. And here, as in the graph we are forming a cycle, but here in the tree we should not form a cycle. Okay, that you have to keep in your mind. Now here, this is nothing but a spanning tree with edges 4 5 2. Now the cost of this is the sum of all these edges. Therefore 4 plus 5 plus 2, that is nothing but 11. The total cost of this spanning tree is 11. And we have another spanning tree also. Now here we took like this 4 1 and 2, and what is the cost here? 7. Therefore comparing with these two spanning trees, which one is minimum? Therefore the minimum here is our 7. Therefore this is our minimum spanning tree. Okay, now in this minimum spanning tree we have two algorithms. One is kruskal algorithm and the prim's algorithm. Okay, now let us first understand about the kruskal algorithm, and let us detailedly know how the kruskal works, and then we shall go for the Prim's algorithm. Now, let us understand it by taking a graph. And first, before doing the kruskals algorithm, we have some procedure or some algorithm for the kruskal. Let us understand the steps of the kruskal algorithm. My algorithm. Now, first we shall go for the algorithm steps. First step. Now, when you are talking about the first step, remove all the loops and parallel edges. Then arrange all the edges in increasing order. Then pick one edge and add to the tree. And fourth one, while adding, check whether you are forming cycle or not. If there exists cycle, discard that edge. Therefore, these are the process we need to follow when you are finding the minimum spanning tree using the kruskals approach. Okay, now in the given graph, we shall by taking this as example, this graph as example, let us see how it works. Okay, now first of all, first step. What is our first step? Our first step is to remove the parallel edges, right? Therefore, first we need to remove the parallel edges, right? Now, what we have parallel edges here? Now, see here, this particular graph consists of 1, 2, 3, 4, 5, 6, 6 vertices, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 edges. Okay, now what is my first step? My first step is remove all the nodes and parallel edges, right? Loops and parallel edges, sorry. Now what is the loop here? Here C to C is nothing but this is one loop we have to remove, and parallel edges from A to B we have two edges, therefore you have to remove that. Now which one you have to remove? The question mark is which one. Therefore the minimum you have to consider and the maximum you have to remove. Okay, therefore minimum you have to keep in the graph and maximum you have to remove, the edge you have to remove. Now let us do that. Now first what I said, loops we have to remove. Okay, now here I removed the loop edge, and then we have to go for removing the parallel edge. Therefore, and that too the maximum edge you have to remove. Therefore, the maximum cost edge you have to remove. Now this is my graph, right? Now what is the next step? Arrange all the edges in the increasing order. Now let us take one table. Let us take one table, and this table consists of two columns. This first column is edges and second column is its cost. Now let us start from the increasing order. That means from smallest edge to the greatest edge. Now among this graph, which one is smallest? B to D and D to T. Therefore, it's your wish. Which one you want to take first, you can take it. Now let us consider the edge B to B comma D, and its cost is 2. Next, we shall go for D comma T. Its cost is 2. Okay. Next, another smallest. Next smallest is 3. Okay. That is nothing but A to C. Its cost is 3. And C to D. Its cost is 3. Okay. And after that 4. That is nothing but C comma B. Its cost is 4. And next we shall go for the next one, that is B comma T. This is its cost is 5. And next we shall go for A comma B. Its cost is 6. And next S comma A. Its cost is 7. And next S comma C, its cost is H. Okay, I hope I covered all the edges, right? Therefore, B comma D, B comma D, 2, D comma T. This one is finished, and this one is finished, and A to C is finished, C to D is finished, right? Next one is C to B, 4 is finished, next one B to T, 5 is finished, next 6 A to B, and next 7 S to A, and next 8 S to C. Now once we have arranged all these in increasing order, now pick one edge from this table and try to form the tree. Okay, now let us pick the first entry. What is our first entry? B comma D, that is its cost is 2. Now I am forming my minimum spanning tree, right? Now B comma D. Therefore this is B and D and its minimum edge is 2. Next edge is D to T. Now D to T, therefore D is already there. I am just connecting here T. Therefore here its edge is 2. Now whenever you are adding an edge to the given tree, okay, you have to see whether when you are adding this edge you are forming any cycle or not. Okay, now when first I have added BD, right? As it is a single edge, therefore we don't expect any cycle. And next I'm adding another edge D to T. Therefore you check whether you are forming a cycle or not. Therefore we are not forming any loop or cycle. Therefore it's safe. Next edge. What is the next edge? A to C. Now let us take A to C separately because we don't have any connected. A to C. Now what is A to C? 3. Next we shall go for a C to D. Okay, now I can add like this, C to D. Therefore this is C to D is also 3. Right? Next after this, just check it. When you are forming a C to D, do you are getting any cycle or not? No, I am not getting cycle. Therefore C to D is okay. Now next C to B. Now when I just give C to B here, therefore I am getting a closed circle, right? Therefore I am getting a cycle. Therefore no need to add this C to B, right? Discard this edge, right? Whenever you are adding that edge, if you are getting any cycle, discard that edge. Therefore this edge C to B is discarded. Next B to T. Now B to T also, if I take B to T, I am getting a cycle here, right? Therefore this is also you have to discard. Therefore discard this edge. Therefore this also discarded. Next A to B. A to B also you will form a cycle. Therefore discard this edge. S to A. Therefore here we have one S to A. Therefore I took like this S to A. If you take S to C, now S to C also you will form a cycle. Therefore no need to consider this edge. Discard this edge. Therefore this is discarded. Right? Now now you have to do this process until you finish all the edges. Now all the edges I have visited and all the edges I have added in the tree, right? The edge which is forming a cycle, I am just removing that edge. Okay, therefore now let us see how we will have our spanning tree. Now just let us see that. Now this is our final spanning tree. This we shall redraw this one. Right, now what is our final spanning tree? B, D, and D to C we have, right, and D to T we have, and C to A, and this is yes. Okay, now this is 2 and D to C is 3. This is 2 and C to A. C to A is nothing but 3 and this is 7. Therefore, our minimum spanning tree cost is nothing but 2 plus 3 plus 3 plus 2 plus 7. Therefore, this is 17. Therefore, this is our MST, minimum spanning tree. This is our MST. Okay. Now, this is the kruskal approach. I hope you understood how how we can find the minimum spanning tree using kruskal algorithm. Okay. Prim's algorithm is used to find the minimum spanning tree from a graph. As I said that minimum spanning tree, what is the minimum spanning tree, and how we need to find the minimum spanning tree using Kruskal's approach in my previous class. Now we shall go for finding the minimum spanning tree using the Prim's algorithm. Now the Prim's algorithm will have one procedure. Based on the procedure, we need to find the MST. We need to construct the MST. Now let us see what are the algorithm, what is the procedure, and what is the algorithm, and then with an example I will explain detailedly how we will construct the MST using the Prim's approach. Now let us see. Here I have some steps, 5 steps. These are nothing but the procedure for the Prim's algorithm, or the procedure to construct the minimum spanning tree using the Prim's approach. Now first one is you have to remove all loops and the parallel edges. Second one, choose any arbitrary node as root node. Check outgoing edges and select the one with less cost. You can choose this one, or create a table with number of vertices, columns and rows, and put 0 in cells having same row and column name, and find the edges that directly connect to the vertices and fill the table with the weight of the edge. And the last one is, if no direct edge exists, then fill the cell with infinity. Now once you did this procedure, once the table has been created, then we can able to construct the minimum spanning tree. Okay. Now here we have two things. One is set outgoing edges and select one with less cost, or you can create the table. First I will show you how to create a table and how to construct the minimum spanning tree, and then we shall go for another method, that is directly choosing the any node and directly constructing the MST. Okay, and in that what are the disadvantages, and based on the disadvantages how we are, that means that disadvantages how you are overcoming in the table approach. Okay, now let us see. Now by using an example, now this is my example graph with 4 nodes and some edges. Now in order to make you understand, I am just adding 2 more edges. Okay, now this is one self loop I am adding here with a cost of 7, and one another edge with a cost of 12. Right. Now this is my example graph. Now let us start constructing the minimum spanning tree by using the Prim's approach. Now in the Prim's algorithm, the first step is nothing but remove all loops and parallel edges. Now in the given graph, the loop is, now what I have added, this is my loop. This is loop edge, self edge. Okay, C is connected to C again. This you have to remove. and parallel edges is nothing but if there exist two edges between two nodes, then that we will call it as a parallel edge. Okay, that means here we have two nodes C and D. C to D we have two connections. Okay, C to D, one connection is of weight 10 and another connection is of weight 12. Okay, these are parallel edges. Okay, now in this you have to remove one. Which one you have to remove? The greater edge you have to remove. Okay, the edge which have the greater weight, that you have to remove. Therefore these two things you have to do as a first step, right? Now let us remove the loop first and then we shall remove the parallel edge first. Now the loops and parallel edges are removed, right? Now this is our given graph. Now for this graph, what we have to do next? Now we have to create a table. As I said, the first one, check outgoing edges. Later on I will explain. Now let us go for creation of a table. Now how we have to create a table? The table rows and columns should be number of vertices in the graph. How many number of vertices are there in the graph? That many number of rows and that many number of columns. Now let us draw a table A, B, C and D, and here A, B, C and D. Therefore here I am constructing one table. Now after creation of a table, now what is the next one? The same row, same column values should be 0. Therefore A to A is 0, B to B is 0, C to C is 0 and D to D is 0. Okay. Now next we have to enter the edges, that is weight of that particular edge. Like for example, if you have here A to B is nothing but how much? A to B is 11. Therefore you just need to add edge here 11. Now A to C is how much? A to C is nothing but we have 5. Therefore here we have to add 5. A to D is nothing but 4. Therefore enter 4. Okay, therefore any edge which have a direct connection and the direct connection, how much weight we have, that weight you have to enter in the table. Okay, and if suppose we don't have any direct connection, then we have to enter infinity. If we don't have any direct connection, that means if we don't exist any direct connection between two nodes, then we have to enter infinity, right? Now next one is B to A is 11 and B to C is, we don't have any direct connection. See here, check, B to C no direct connection, right? Therefore here as we don't have any direct connection, just go for infinity. Next B to D is nothing but 5 and C to A, yes we have 5, right? Next C to B we don't have any direct connection, therefore this is also infinity. C to D we have a connection that is of 10 and D to A we have a connection of 4. D to B we have a connection of 5. D to C is nothing but a 10. Okay, now this table is ready. Now table is created. Now let us try to construct the minimum spanning tree. Okay, now first we have to consider the first row of the table. Now in this first row, which cell is having minimum value, that you have to choose. Now here in this row we have 0, 11, 5, 4. Therefore which one is minimum? 4 is minimum. Therefore 4 is for which edge? A to D. Therefore here you have to construct a minimum spanning tree, okay, by considering A to D. This is the edge. Now this edge weight is how much? 4. Okay, next go for the second row. Now the second row, which one is minimum? 5 is minimum. Therefore this 5 is an edge for which edge? 5 is a value for which edge? Therefore B to D. Therefore here we are going for B to D. Now its value is 5. right? Okay. Now another thing you have to notice is while you are adding the edges into the minimum spanning tree, you have to check whether you are forming a cycle or not. Okay, if suppose if any if after adding any edge, if you are forming a cycle, then you should not add that edge. You have to remove, you have to discard that edge. Therefore here, a first I have added a to d, and then I am adding a to d to b. Okay, now when I add d to b, I am not forming any cycles, therefore happily I can go for the next edge. Now go for the third row. Now in this third row, which one is minimum? 5 is minimum. Therefore 5 is for which edge? C to A. Therefore it is for C to A. Therefore now I am taking C to A. Now what is the edge value? That is 5. Right? Now do I am forming any cycle? No, I am not forming any cycle. Therefore go for the next one, that is fourth row. Now here 4 is minimum. Now 4 is nothing but D to A. D to A already finished. Therefore don't consider this one. Next minimum is 5. Therefore D to B. D to B is already finished. Therefore don't consider, go for the next minimum. Next minimum is 10. Therefore D to C is 10. Now if I consider D to C, therefore now what I am forming? I am forming a cycle, a loop, right? Therefore when I am adding any edge, if there is a chance of forming any loop, don't consider that edge. Therefore discard that edge. No need to enter that edge in the minimum spanning tree, right? Now I have discarded this edge, right? Still any other rows are left over? No, everything is covered. Therefore now stop the process and now just check it. Now this is our minimum spanning tree. This is our MS tree, right? Now let us find the cost of it. What is the cost? Add all the edges. Therefore 5 plus 4 plus 5, that is nothing but a 14. 14 is our minimum cost, right? Therefore this is our final MST. This is our final minimum spanning tree using the Prince approach. Okay, this is a first method, that is creating a table approach. Now as we said that another method exists, that is check outgoing edges and select one with less cost. Let us see that one also. Now let us see the second one. Now in the given graph, first you take any edge, any node from in the given graph. You take any node, either you can take A, B, C or D. Now I am taking A. Now just consider the node A, and from node A, how many edges are there? 3 edges, that is 11, 4 and 5. Among this, which one is minimum? 4 is minimum, right? Now this 4 is leading to which edge, which node? D. Therefore here I can consider this like this, A to D, and its weight is 4. Now from D's point of view, that means from D, again you have to check the edges, right? Now from D, how many edges are there? 4, 5 and 10, right? Now which one is minimum? 4. Already 4 is finished, right? Now the next, out of 5 and 10, which one is minimum? 5 is 10. Therefore you have to consider the 5, right? Now this 5 leads to B. Therefore D to B. D to B. Now this is of how much cost? This is of 5. Okay. Now from B. Now again check how many edges are there from B. Now from B we have 2 edges. One is 11 and one is 5. Already 5 is finished. Now if you have to consider 11. Now if I consider 11, I am forming a cycle, right? That means I should not consider 11. Okay, I should not consider 11. Now I have to discard this edge, right? Now next. Now from B, I am not going anywhere again. Yes, from B, I am not going anywhere. I am just stucking up here only, right? I am neither going to C or nothing. Why? Because there is no direct connection from B to C. There is no direct connection from B to C, right? Therefore, as we don't have any direct connection from B to C, then we are not able to construct our MST. Okay. Therefore, the first approach will be successful if suppose the first approach will be successful if we have connection among all the nodes. Okay. Therefore, that's why we are going for the table. As we don't have direct connection from B to C, therefore we can't form a minimum spanning tree. Okay. Therefore, I hope you understood the difference between the first one and the second one. The first one is directly constructing the tree, taking one arbitrary root node, and then just checking the which one is a minimum node, and then we are choosing that edge, and then from that uh, node again you are checking another minimum, like that you are doing. And the second one is you are constructing the tree, constructing the table. Okay, you are creating a table, and then from the table you are constructing the minimum spanning tree. I hope you understood Prim's algorithm. And next we shall go for the second method of the Prim's algorithm. We have another method also uh, uh, to calculate to construct the MST using the Prim's algorithm. Let us go for the second method. Now let us go for the second method, Prim's method. Prim's approach second method. Already the first method I have discussed by creating a table and this. Now we shall go for the second method. Now these are the rules for the second method. This is the algorithm procedure for the second method. First, remove all loops and parallel edges. Next, construct an adjacency matrix with number of vertices. Then we have to consider three arrays. One is MST, parent and key, and all these array sizes are nothing but how many number of vertices are there, that many number of that much size of the array. And MST is a Boolean array, and initially it has to initialize with false. And next a parent array with -1 and keys with infinity. Then first consider any one vertex and try to add that vertex into the minimum spanning tree and update the MST and parent key arrays. Then repeat this process until you add all the vertices into the minimum spanning tree. Therefore, this is the procedure. Now, this procedure we shall understand by considering one example. The same example I am taking, which I have explained the first method, the same example I am considering here. Okay. Now, let us go for the first step, that is nothing but remove all loops and parallel edges. Now, in the given graph, we have one loop and one parallel edge. Therefore, first we shall remove that loop and the parallel edge. Then next, second one is we have to construct an adjacency matrix. Now let us construct the adjacency matrix here. Therefore, here you can construct a table or adjacency matrix. Now here I am constructing an adjacency matrix. A with how many number of vertices are there, that many number of rows and columns in the matrix. Now all the diagonal values, that is the self edges, should be 0. That means the row and column values, if any row and column values are same, in that we have to keep 0. Now here, just in order to make it clear, now let us take the adjacent, the diagonal values as 0. Here all the diagonal values are 0. Next, same as usual in the first method, how you have entered the weight. The same way here also you have to enter the weights. Now A to B, how much you have? You have 11. A to C, A to C you have 5. A to D 4. And next B to A, B to A you have 11. And B to C, B to C you have no, you don't have any direct edge, therefore here you have to enter it as infinity. And B to D, B to D is 5. And same C to A, C to A is 5. And C to B you don't have any direct edge, therefore here infinity. And C to D is nothing but 10. And D to A, D to A is 4. And D to B is 5. And D to C is 10. Right? Now after creating this particular adjacency matrix, now we shall start the procedure. Now first what we have to do, according to the third step, consider 3 arrays with size, number of vertices, that is nothing but all the arrays, that is MST, parent. Here I took 3 arrays, MST, parent and key, and all these arrays should have how many number of columns? We have 4 columns, that is nothing but how many number of vertices in the given graph, that many number of columns, A, B, C, D, A, B, C, D, and this is also A, B, C and D. After considering all these 3 arrays, now first initialize these arrays with the minimum value. Now here MST is a boolean array, therefore I am initializing it to false. All the column values are false here. Now in the parent, parent array, now the parent array, the first column I am considering as -1. Why? Because I am starting my procedure, that means I am constructing my MST by considering A first. I am starting with node A. Therefore, the node as no, I am starting with node A. Therefore, node A don't have any parent. That's why as A doesn't have any parent, therefore the parent is a root of the minimum spanning tree. That is A is the root of the minimum spanning tree. A does not have any parent. That's why here -1. Therefore, parent array will tell you about parent of that particular node. Okay. Therefore, if now A's parent is -1, that means A is the root node. Suppose if we have B and we have A, right? That means B's parent is A. Suppose if you have here D, therefore C's parent is D, like that. Okay. Therefore, here parent array will tell you about which node, who is the parent of which node. Okay, that is parent array's purpose. Next, key. Initially in the key we have to keep, actually we have to enter edges. Therefore, initially what we are doing, we are entering infinity. Okay, and first we are considering A. Therefore, initially what you have to do, you have to consider this as 1. That means A you are taking it as 1, or you can take even as 0 also. Why? Because minimum, the starting value you are considering as 1. Therefore, the minimum value you can take it as 1. Okay. Now let us construct the minimum spanning tree. Now first I have considered A, and after considering A, I am just updating it. What I am updating? I am updating my MST first. How I am updating? I am updating MST from false to true. What is the meaning of that? The meaning of that is you are constructing the MST by first adding a vertices A. That means by adding a vertex into the minimum spanning tree. Okay, that means you are including A in the tree. You are including A in the tree. Therefore, here as I have included A in the tree, now A's column you have to make it as true. That means A vertex has included in the, what you have to do, the parent is nothing but A's parent is -1, you have to update this one, and then you have to update the key. Okay, therefore update the MST, update the parent, update the key. Now let us go for updation of the key. Now which node I have added? Node A. Therefore just observe the table. Now in this, consider the A row, node A row, okay, and just consider all the values, okay, and compare all these values with the, and in this which one is minimum, that value you have to update here, right? Therefore now A to A you just ignore it, rest of the other things like B, C, D, these values you have to consider. Now here the A to B value is how much? 11, but here how much we have? Infinity. Therefore 11 is small, therefore update it to 11. Similarly, next one is C. Now here the value for C is infinity, there is 5, therefore 5 is minimum, therefore update it to 5. And the same thing here, we have infinity and here we have 4, therefore same, update it to 2. Now after updating, then now what you have to do, you have to choose the next minimum. That means now the node A is included in the optimal, in the minimum spanning tree. Okay, now next what I have to do, I have to include the another node. Now if I want to include the another node, now I have to just check the key. Okay, now in this key, which one value is minimum, you have to check. Now among 1, 11, 5, 4, 1 is minimum, right? 1 is nothing but A. A is already entered, therefore you should not consider this one, right? Next minimum among 11, 5 and 4, which one is minimum? 4 is minimum, that is D, right? Therefore now we have to enter D, you have to include D, right? Therefore now what I'll do, I'll just update my key. Now step 2, just the same key. Now what are our values? 1, 11, 5 and 4. 4 is minimum, right? 4 means D. Now D should be included in the MST. Now what I'll do, I'll just make it as true, right? And then D value here in the key, what it is? 4, right? Now you just observe the table. Now where is D row? Just go to that D row and just check the 4 in the D row. Now 4, this is a 4 is nothing but the weight of D to A edge, weight of D to A edge. That means D's parent here is A, okay? D's parent here is A. Like that you can find the parent, okay? First you have to see what is the weight of D and what is the weight of D, and that weight you have to check in the adjacency table where it is in the D row, you have to check it, and for that the corresponding column value what we have, that is nothing but the parent of that particular node, okay? Now here the parent of D is nothing but A, therefore here you have to update the parent table now, okay? MST table is updated, now you have to update the parent table. Every time you have, whenever you are including any node, you have to update the MST, parent and key, right? This process should be repeated every time. Whenever you are updating whenever you are including any node, you have to update MST, you have to update parent, you have to update the key. Now MST is updated, now I am updating the parent. Now who is D's parent? D's parent is A, right? Now after including D, now update the key also, right? Now consider the D row, right? Now you just need to update the weights of the D row with the key, right? Now if you compare it, 1 and 4, if you compare here, then this is 4, this is minimum, no need to change here. Now when you compare B and here B, therefore here it is 11 and here it is 5, therefore minimum value you have to update, therefore update it with the minimum value. Next one, C. Now when you consider C column, therefore here C column is how much? 10. Now here is 5, therefore it's already minimum. And here 4, as we are considering D, therefore no need to consider this. Now next we shall go for the finding the next node, which node I have to include next. Now this process, every time we have to repeat until we finish including all the nodes, right? Now see here, now in the third step, what we are doing again? In the third step, just the same values, the current values of the key is 1, 5, 5 and 4. Okay, now let us consider here how many nodes are how many nodes are included in the tree. A included and D included, right? Now what you have to do, you should not consider this one, means even if you consider it's already visited, therefore don't bother about this, therefore A and D don't bother about this, right? Now check, now the remaining, check the remaining nodes, the leftover nodes. Now what are the leftover nodes? B and C. Now among this, which one is minimum? The minimum is anything, because both are same, therefore you can take any one. Now let us consider the first one, that is nothing but B. Now what we have? B 5, right? Now I am including B into my BST, right? Now let's, whenever you are including any node into the minimum spanning tree, as I said that you have to update the MST and then parent and then key. Now I am updating my MST. Now I am just updating false to true. Okay, which node you are including, in that corresponding column only you have to update, right? Now after updating MST, now update the parent. Now just check it. If you want to know the parent of B, you have to go for checking the adjacency matrix in the B row. Okay, now in the B row, where is 5? Okay, now here we have 5. Now 5 is the 5 is the weight of which edge? B to D. That means here B's parent is D. Is it clear? B's parent is D. Therefore enter the parent of B. Now parent of B is D. Right? Now parent is updated. Next we have to update our key. Right? Now update with the same row. Now B row. Now already 1 is finished. Don't consider the A's column. Okay, now consider B's column. Now here B to B already we have visited, we are including now B. Therefore the remaining one, next one is nothing but a C. Consider C. However, D is visited, no need to consider D also. Therefore only one is remaining, that is nothing but C. Now what do you have here? C, infinity, but here we have 5. Therefore no need to change, because already minimum value you are maintaining here. Understood? No need to change that. Right? Now as it is. Okay, key also updated. Now how many vertices we have included? A, D and B. Right? Now next, let us go for the next vertices. Now next inclusion. Now for that again you have to check the key. Right? Now let us see what are the current values of the key.
Now the current values of that key are 1, 5, 5 and 4, right. This is A, B, C and D. Already A is finished, you have entered, B also it is finished and D also finished, right. Now the remaining one is nothing but what? C, right. Now you have to include C, right. Now when you are including C, what I said, you have to update MST, parent and key. Now let us update first MST. C's column, corresponding column, you have to make it as true, and now update the parent of C. Who is parent of C? Let us see that. C's column you have to consider, C row you have to consider. In C row where we have 5, therefore C to A we have 5. Therefore the parent of C is A. Therefore write here A. Right? Over. Now update the table. Update the key. Right? MST is updated. Parent is updated. Now key should be updated. Now if you just consider the C row, now already 1 is finished, that means A is finished, B is finished, now C also included, now D also finished. Therefore no, we don't have any other value to update. Now this is the end, right. Now C is included in the MSC. Now all are included, all the vertices are included in the MST. You have to do this process until your MST array becomes, all the columns of MST array becomes true. You have to do this process again and again. Okay, you have to do this process again and again. Okay, now let us finally create our minimum spanning tree. Now just let us create the MST. Now for that you have to consider the parent array. Okay, you have to consider the parent array. Now let us take the first one. What is our first column here? A. Now A's corresponding parent, who is, what is it? What we have? Minus 1. Minus 1 means A is a root node. Therefore take A as a root node, right. Next, what is the next one? B. Who is the parent of B? Parent of B is D, right. Therefore parent of B is G. Now instead of going like this sequentially, now let us see, already A is a root, right. Now you just check in the parent array, as A as parent, do we have any other node connected to A? Okay. Okay, now see here, A as parent, A is connected to how many vertices? C and D, right. Therefore you can connect it to D and we can connect it to C. Why? Because A is a parent of C and A is a parent of D, right. Okay, now these two is finished. The remaining one is B. B's parent is D. Therefore here B and B's parent is D, right. Now what is A to D? A to D is nothing but A to D is 4, right. A to C, A to C is 5, and what is D to B? D to B is 5, right. Now what is the cost of this? Cost of this particular MST? The cost of the MST is 5 plus 4 plus 5, that is 14. Okay, now this is our final MST which we have derived from the parent array, Okay, therefore in this way we are going to construct the minimum spanning tree by using the adjacency matrix, MST, parent and key arrays. I hope you understood the concept, Prim's algorithm, the first approach, second approach, and the third approach. And I even explained about the Kruskal algorithm. Therefore, I hope you understood. Thank you.